All right, so this is going to be kind of a quick generic look at how we're using definite integrals to find the area between a function and the x-axis. So this first one is kind of the most general one. And also when we're doing this, our goal every time, no matter what, is to take the top function. We're going to integrate the top function minus the bottom function. And we also have to this is basically going to be where they meet on the left-hand side, where they have a point of intersection on the left-hand side, and this is where they meet on the right-hand side. And if they don't meet, like actually cross, then you'll be given arbitrary places to start from the left and the right. So in this particular picture here, where this is your left and this is your right. So my lower bound is A, and my upper bound is B. And I only have one graph, and it's sitting up here, and it is what I would be considering on top. So that would be my top function. So this would be I'm integrating f of x, and I subtract the bottom function. In this case, the bottom function is down here on the x-axis. This is my bottom function, and that is just the equation y equals 0. So generally, this would be f of x minus 0, and then we tag a d of x on there for notation. And obviously, if you subtract 0 from something, it doesn't change the value. So you're really just integrating f of x a to b. We've sort of been doing that without worrying too much about this being 0. But if I look down here, the situation is sort of flipped. I'm still a to b, so I'm still left to right. Again, arbitrary bounds being given to you to find the area between two particular points. So I still have that a to b. But notice that now this is on the top. And that, again, is the equation y equals 0. So now the top function is 0. And from that, I have to subtract the bottom. And I didn't put it down here, but I'm just going to keep using f of x. So this is below it. So this would be my bottom function. And so it would be 0 minus f of x. So the location matters. Remember, this is considered a negative area underneath here. So now if I'm trying to find the physical area of a shape, physical area is considered positive geometrically. So when I do the subtraction of this area, which would normally be considered negative, it will record it as an actual positive area. So when we get into things that are a little bit more elaborate, like these three, notice that the difference is on this one, again, I don't necessarily have any values recorded on here, but this left bound is definitely going to be considered 0. And I need to put in this point right here, because at that point I go from being above to being below, and then it looks like we're going to end here, so I've got to have an arbitrary value there. So this officially would be written two ways. So you would start by integrating from 0 to a. That's an a, not a 9. And I will quickly make that into an a for you. We're going to look at this part first. So again, on this, this is on top until I get right here. So that's my top function, which again, I'm just going to call that f of x. And the bottom is here, which is 0, so it'd be f of x minus 0. Again, I'm going to put that in for now, but eventually you're not going to need that. And then I've got to shift gears, because I got to add another piece, because I have a whole second piece down here, which is a negative area, but it starts at A and goes to B. So I have A to B, and this is kind of how those properties we looked at earlier come into play. But now this is on top. So that's back where I'm now going 0 minus, and my function is down here, so minus f of x dx. And again, if I wanted to start to get familiar with this, I would probably not write this 0. I wouldn't need to write the 0 because it is redundant. And here I don't really need to write this 0 either, as long as I remember that this has to be a minus. And so that's kind of a shorter hand way to write this. Now this little arrow is here because it's trying to indicate, well, this piece of it over here in green, right here that I just circled, this piece of it right here, is a negative area. but when I apply this minus or negative sign to it, it actually acts the same as if it were up here. And so this function, if this is the same function, if I want to shortcut this in my calculator, I could do it from 0 to b. So again, there's my starting point, there's my ending point. Even though this a is in the middle, if I recognize that this piece is just going to be reflected up here, I could use the absolute value of f of x, and it should give me my answer. Now, we haven't talked about integrating absolute values, so this would be a way to check it in the calculator, and the calculator would then always give you positive answers, and it should work. And then our last scenario is right here where I've got two functions, and again, I've got, you'll notice over here on the left, I'm going to call that A, and then it looks like right here they intersect, that's B, and they intersect again at C. So I'm going to use a couple different colors here. I'm going to use blue for f of x, so it curves like this, and I'm going to use red for g of x. And so this isn't with the x-axis anymore. This is literally two separate functions, and you're finding the area between them. So now you've got to be pretty careful. You have to find the points of intersection, and you have to do top minus bottom. So this integral would become, starting on the left, you would go a to b, because that's the farthest point of intersection on the left, and then this is where they cross again in the middle. And notice the blue switches from top to bottom, and vice versa for red. So this is the top, and this is the bottom. So in this particular case, the top is my blue function, which is f of x. So this would be f of x minus the red function, which is g of x. And I'll put my little dx in there, plus the second piece, so I just took care of all of this. The second piece starts from b and goes to c. So I have a second piece in here. And now the red function is clearly on top. That's g of x. So I've got to do top minus bottom. So I've got to switch gears. Minus the blue is on the bottom, f of x dx. And I have two separate pieces to do, and then I add those two areas together at the end. So that's kind of the very generic situation of top minus bottom when you're finding the area between two functions or two curves. Sometimes that curve or function is just the x-axis, and sometimes it's actually another function. So I hope that helps maybe give you a little bit of a visual of what's going on in finding these particular areas between functions.